Welcome to PreMath. In this video, we have got this obtuse triangle ABC, as you can see in this diagram, such that its angle BAC is 120 degrees. Its side length AC is 2, whereas its side length BC is 4 times square root of 3. And now our task is to calculate this side length AB. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And in this video, I am going to share with you with two different approaches. So therefore, please watch the video till the very end. And here's our very first method. We are going to use the Pythagorean theorem. And we know that we can apply the Pythagorean theorem only on the right triangles. And we know that this is not a right triangle. So therefore, we have drawn this right triangle ADC by extending this side length AB all the way to this point D. And then connecting this point C with this point D. And now we can see one of the side length of this right triangle is 2. And now let's recall this straight angle. This is 180 degrees and this angle is 120 degrees. So therefore this remaining angle has got to be 60 degrees. And we know this is our 90-degree angle, so therefore this third angle has got to be 30 degrees. So therefore we can see that this right triangle ADC is our special 30, 60, 90 triangle. And here I have copied down this right triangle ADC over here. And here we can see that 30 degrees is our smallest angle. So the side opposite to that one is going to be our smallest leg. Whereas this 90 degree is our largest angle. So the side opposite to that one is going to be our longest leg. So therefore, in such kind of 30, 60, 90 triangle, the longest leg is twice the smallest leg. If the smallest leg is 1 unit, then the longest leg is going to be 2 units. So therefore, our this side AD turns out to be 1 unit. So therefore, the third leg of this 30, 60, 90 special triangle is going to be square root of 3. And here's our next step. Let's focus on this right triangle BDC. Let's assume that this side length AB is x unit. Then this whole side length BD is going to be x plus 1. And now we are going to use the Pythagorean theorem on this triangle BDC. And here's our Pythagorean theorem, a square plus b square equal to c square. Let me go ahead and call the longest leg as our side c. I'm going to call this side lowercase a and this side lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is x plus 1. So this is going to become a whole square. B in our case is square root of 3 whole square equal to c is 4 times square root of 3 whole square. And now let's recall this famous identity. A plus b whole square could be written as a square plus 2ab plus b square. We are going to apply on this binomial. So this is going to become x square plus 2x plus 1 plus this square and square root. They undo each other. So we got 3 equals to 48 on the right hand side. And here in the next step, 1 plus 3 is going to give us 4. And now let's go ahead and subtract 48 from both sides. This is gone. So therefore, x square plus 2x minus 44 turns out to be equal to 0. And here we got a quadratic equation and we are going to solve it by using the quadratic formula. And here's our quadratic formula. And here we can see our coefficient a is 1, b equals to positive 2, and c constant is negative 44. So let's go ahead and fill in the blanks in this quadratic formula. So x equal to minus b means negative 2 plus or minus square root of b is 2 square minus 4 times a is 1, c is negative 44, all over 2 times a is 1. And if we simplify everything, it turns out to be negative 2 plus or minus square root of 180 divided by 2. And now let's focus on this square root of 180. And here I have copied it down. And if we simplify this thing, this turns out to be 6 times the square root of 5. So therefore, I'm going to replace this square root of 180 by this 6 times square root of 5, as you can see in this next step. And now we can put this one as a partial fraction. I can write x equal to negative 2 divided by 2 plus or minus 6 times square root of 5 divided by 2. And here 2 divided by 2, that is going to give us negative 1. And here 2 goes into 6 3 times. So therefore our x value turns out to be negative 1 plus or minus 3 times the square root of 5. And now since x is the side length, so therefore we are going to ignore this negative sign. So therefore our side length x turns out to be negative 1 plus 3 times the square root of 5 units. So therefore our this side length AB, which is represented by x, turns out to be negative 1 plus 3 times square root of 5, and that is equal to 5.71 units. And here's our second method, and we are going to find the value of this side length AB by using the law of sines. And now let's focus on this triangle ABC. For this vertex A, I'm going to call this angle alpha. And the opposite side is going to be lowercase a. For this vertex B, I'm going to call this angle beta, and the side opposite is going to be lowercase b. And finally, this angle is going to be gamma, and this opposite side length is going to be lowercase c. And now our task is to find the value of this side length AB, which is represented by c. And now let's recall the law of sines. Sine of alpha divided by side length A equal to sine of beta divided by lowercase b. And in our case, our angle alpha is 120 degrees. Our side length A is 4 times square root of 3, and our side length B is 2. And this way we can find this angle beta. So let's go ahead and fill in the blanks. So we got sine of 120 degrees divided by side length A is 4 times square root of 3 equal to sine of beta divided by 2. And we know our sine of 120 degrees is square root of 3 divided by 2. So therefore I'm going to replace it over here. As you can see in this next step, I have replaced this sine of 120 degrees by square root of 3 divided by 2. And here in this next step, square root of 3 is gone with this square root of 3. So therefore the left hand side turns out to be 1 divided by 8 equal to sine of beta divided by 2. And now let's multiply both sides by 2 to isolate sine of beta. So therefore sine of beta turns out to be 1 divided by 4. And we know 1 divided by 4 is same as 0.25. So therefore our angle beta is going to be equal to sine inverse of 0.25. So therefore our angle beta turns out to be 14.47 degrees. So therefore our this angle beta turns out to be 14.47 degrees. And now we know that the sum of the angles in this triangle alpha plus beta plus gamma is going to be equal to 180 degrees. And here I replace alpha by 120 degrees and beta angle by 14.47 to solve for angle gamma. So therefore our angle gamma turns out to be 45.53 degrees, as you can see over here. And here's our next step. We are going to apply another law of sines. C divided by sine of gamma equals to B divided by sine of beta. So therefore we can write C divided by sine of gamma is 45.53 degrees equals to b value is 2 divided by sine of 14.47 degrees. And here in this next step, sine of 45.53 degrees is 0.7136. And likewise, sine of 14.47 degrees is 0.25. And now let's go ahead and multiply both sides by 0.7136 on this side and 0.7136 to isolate c. And here we can see this cancels out. And if we simplify the right hand side, our side c turns out to be 5.71 units. So thus this side C turns out to be 5.71 units. So thus our AB length turns out to be 5.71 units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.